The sun is the life giver for every living being on Earth. Without it, life on our planet would simply not be possible. In its absence, the Earth would plunge into darkness, and the entire planet would be buried under heaps of ice. Without the sun's warmth, the existence of life itself would be impossible. But this cycle has been ongoing for about 4.5 billion years. Will this cycle continue forever? Will our sun and the solar system remain eternal? Will the sun continue to shine like this forever? Or will there come a day when it meets its end? So friends, the thing about endings is that everything on this earth has an end. Not just living beings, but also inanimate objects. It is said that a diamond is forever, but even a diamond is not eternal. After lakhs or crores of years, that shining diamond will turn black, transform into carbon, and become coal. By this logic, our sun will also meet its end. But before we talk about its end, we need to understand how the sun began in the first place. So let's first explore how our sun was created. How did the solar system come into existence? Billions of years ago, where our solar system exists today, there was nothing. But the formation of the sun and all the planets of the solar system took place about 4.5 billion years ago. Now, nothing in this universe happens without a reason. There's always a cause behind every miracle or event. There was a massive reason behind the formation of the solar system, and that was a gigantic nebula, which we later named the Solar Nebula. This nebula was a massive cloud of gas, and a part of this nebula, about 5 billion years ago, collapsed due to its immense mass. Over time, this collapsed portion, under its own gravity, began to take shape. From this, the sun and all the planets of the solar system were formed. The theory that explains the formation of the sun and the solar system is called the Nebular Theory. According to this theory, at least one or more supernova explosions must have occurred within that massive gas cloud. These explosions caused a portion of the giant gas cloud to collapse or scatter, separating a large amount of raw material from it. Gradually, due to motion and pressure, this large portion of the gas cloud began to rotate and heat up rapidly. Due to this speed and pressure, a significant portion gathered at the center. The remaining material continued to orbit around it in a circular motion, leading to the formation of a massive protoplanetary disk. This entire process took crores of years, and as time passed, the temperature began to cool slightly. After this, the central seed-like portion, composed of hydrogen and helium, came into existence as our sun. From the raw material orbiting around it, our Earth, other planets, moons, and many other small and large bodies of the solar system were formed. Thus, friends, the sun, along with all the planets and moons, formed our solar system. The largest body in our solar system is our sun, which alone accounts for 99.9% of the total matter in the solar system. The sun has the highest mass in the entire solar system, with a diameter of 1,392,000 kilometers. The sun may not appear that large to us, because it is 149,600,000 kilometers, approximately 150 million kilometers, away from Earth. But in reality, the sun is 1,000,000 times larger than Earth. It takes sunlight about 8 minutes and 16 seconds to travel the 150 million kilometers from the sun to Earth. Unlike Earth and other planets, the sun is different. It is in fact a star. It is one of the approximately 100 billion stars in our Milky Way galaxy, and the sun belongs to the G2 category of stars, which make up about 10% of the stars in our galaxy. Just as Earth and all the planets orbit the sun, along with all its planets, moons, asteroids, and the entire solar system, orbits the center of our Milky Way galaxy. It does so at a speed of 220 kilometers per second, or about 800,000 kilometers per hour. It takes our sun approximately 250 million years to complete one full orbit around the center of the Milky Way. The sun's surface is composed of hydrogen, helium, iron, oxygen, silicon, sulfur, magnesium, carbon, calcium, and chromium. However, apart from hydrogen and helium, the other elements are present in very small quantities. Thus, the sun is primarily a massive sphere made of hydrogen and helium. The innermost part of the sun is called its core, where temperatures reach their peak. The core of the sun can reach temperatures as high as 15,600,000 degrees Celsius, while the sun's surface, which always appears radiant and illuminated to us, maintains a temperature of about 6,000 degrees Celsius. Interestingly, the core of our Earth, which is the center of our planet, also has a temperature similar to the Sun's surface, around 6,000 degrees Celsius. So far, friends, we've learned about the Sun's origin and the nature of this star. But now, let's explore how the Sun will meet its end. Born about 4.5 billion years ago, our Sun converts 657 million tons of hydrogen into 653 million tons of helium every second. Now pay attention to the difference between these two figures. Friends, 4 million tons of hydrogen are not converted into helium, but instead transform into energy. This energy is released from the Sun and spreads into space in all directions. This is the energy we receive on Earth as sunlight, and it reaches all the planets. This energy is so immense that the amount of light reaching the planets is only a fraction of what spreads across the universe. In this way, our Sun is constantly losing its matter every second. But how long will this continue? The answer, friends, is that this will continue for approximately another 5 billion years. After that, the hydrogen in the Sun's core will be depleted, causing the core's temperature to exceed its limits. The Sun will begin to swell, becoming about 100 times larger than it is now. When a star swells like this, it is called a red giant. Our Sun will one day become a red giant star. As the Sun continues to expand, its diameter will grow so large that it will engulf the planets Mercury and Venus. Then it will be Earth's turn. By that time, all humans and living beings on Earth will have perished. After some crores of years, the Sun will have only helium left instead of hydrogen, and this helium will begin to convert into carbon. As a result, the Sun will swell even more, expanding to cover more than half of the solar system. Eventually, its outer layers will peel off like a shell and scatter into space. These outer layers will gradually cool, solidify, and disperse. This process will continue, and ultimately, only the Sun's core will remain like a seed, roughly the size of Earth today. Yet, it will still be immensely hot beyond any limit. This stage of the Sun is what physicists call a white dwarf. In this way, our Sun will one day take the form of a white dwarf star. Over crores of years, this white dwarf will lose its temperature and energy, eventually extinguishing and becoming like a lump of black coal. Thus, after destroying the living world on Earth and the entire solar system, our Sun will also come to an end. But friends, don't worry, because this will take at least 5 billion years to happen. In the universe, many stars born before or alongside our Sun have already met their end. Some have become red giants, others have turned into white dwarfs, and many have become like extinguished lumps of coal, mere dead remnants. But alongside this, new stars are continuously being born in the universe. Now, friends, if you're wondering why our Sun didn't become a black hole or a supernova, let's address that too. As I mentioned earlier, every star is born from a solar cloud or solar nebula. However, the star that is born is either very large or relatively small. Smaller stars like our Sun, or those slightly smaller or up to 3 or 4 times larger, eventually become red giants. After that, they shed their outer layers to form a planetary nebula, become white dwarfs, and ultimately end up as extinguished lumps of coal. But stars that are 8 to 10 times more massive than our Sun become red supergiants as they approach their end. The explosion that occurs from a red supergiant is called a supernova. The remnants of a supernova's core lead to 2 possible outcomes. The star either becomes a tight neutron star or a black hole. A comparatively smaller star whose gravity fails to engulf light becomes a neutron star. But a highly massive star whose gravity becomes so immense after a supernova that it engulfs even light becomes a black hole. So, friends, a star typically meets one of 3 fates. It either becomes a white dwarf and extinguishes, turns into a neutron star, or becomes a black hole. That's all for today, friends. And finally, let me tell you that a star, or rather our Sun, exists in the 4th state of matter. It is neither a solid nor a liquid nor a gas. If you think the Sun is burning with fire, there's no fire or furnace there. It exists in a distinct 4th state of matter called plasma.